Okay, good morning class. So today we're looking at trigonometry, 2D and 3D problems. Okay. We're looking at example 1 on page 128, is that correct? Page 128, and this is for exercise 4 on page 128. Okay. I'm going to make this a bit smaller. Cut that already because I'm now going to move the diagram over. Okay. Let's familiarize ourselves with the diagram quickly. We are told that in the figure B, C and D lies in the same horizontal plane. So B, C, D we assume is on the ground. Okay, we always visualize that that's on the ground. Okay. Where is the ground? Then we are told that AB is a vertical pole. So vertical is standing up straight. So then that means to say that the pole is 90 degrees to the ground. Can you see that, people? So there is 90 degrees as in the diagram there. Also ABC, this angle here is also 90 degrees. Can you see that, people? Okay. So both is going to be 90 there. Then we are told that the angle of elevation from D to A is 60 degrees, which is that angle there. Then we are told that BC is X, which is also marked in the diagram. Then we are told that CBD is 30 degrees, which is also marked there. And then we are told that that angle theta, which is also marked there. So everything in the diagram is in the introduction. Did you see that, people? Alright. First question says, prove that BD is equal to that. So I can move this over. I'm going to do that, so that we can have space. Is that okay, people? Right. So we need the space. So the question says, number 1, prove that BD is equal to x over 2 into the square root of 3 plus 1 over tan theta. Okay. So where do we start? We start by looking at where is BD. So BD is this length here. Then we look at the formula given. The formula has the square root of 3, it has a tan of theta. So you see here, it has a tan of theta here. So definitely I must work in this triangle somehow. Can you see that, people? Right. So let's start. And also BD is the link between the two triangles. Last year we spoke about that extensively. Look at the link between the two triangles. Not so? So let's go. We in triangle BDC. So what did we do? We started drawing this diagram. Drawing the triangle we're working in. Now some of you see it easily. Okay? But it doesn't come so easy to all of us. Okay? Sorry, that is 30. It doesn't come easy for all of us. Okay? So if you can do it without drawing the triangle on the side, no problem. Okay? You'll see me drawing it on the side. So it will give the other learners also the opportunity to score marks in this question. Okay? So there we got that triangle. So what can we do? Is this a right angle triangle? No. So automatically we know we must use the sine, cos, or area rule. Sine rule, cos rule, where you get a tan, area rule. Okay. In non-right angle triangles. Okay, so people, let's look at what we have. We need BD. Okay. What do we have? We have AC. And we got the included angle. Can you see that, people? We have two lengths and included angle. Cos. But then that is going to give us DC. That is of no help. So we take one step back. We look again. We see, but hang on. We are given a lot of angles. We are always given more than one angle. What comes to mind immediately? Sine. Not so. So it's going to be sine of theta over x. Sine of theta over x is equal to sine of 30 over DC. But I don't want DC. However, it's a sine of angle C over BD. And that is what I want. Not so? So in other words, what do I need? I need to know the size of angle C. So what is angle C equal to? 180 minus 30 minus theta. Not so? Which is the same as 180 minus 30 plus theta. You all agree with that? I heard somebody saying 150 minus theta, which is also correct. Okay? But if you're going with 180 minus theta, sorry, 150 minus theta. Did I say 150 minus theta? Yeah. If you're going with 150 minus theta, then you must go back and say 180 minus to apply the reduction formula. You understand? So, just keep it as 180 minus 30 plus theta. Because 180 plus 180 minus 270 plus 360, just keep it like that for now. Okay? So if you apply the sine rule, so that angle there is 180 minus 30 plus theta. So that would simply be BD over sine 180 minus 30 plus theta should be equal to x over sine theta. You all agree with that? So in which quadrant is 180 minus theta in? Second quadrant. Is sine positive or negative? Positive. So that is going to be BD over sine 30 plus theta equals x over sine theta. But we want BD as a subject of the formula. You would agree with that? So we cross multiply, so take it up. So BD sine theta is equal to x sine 30 minus plus theta. We divide both sides by sine theta. It then gives me x sine 30 plus theta over sine theta. Let's say, hang on, x is on the right place and everything else not yet. Okay, but what does this remind us now of, people? What does this remind us of? Doesn't that remind us of compound angles? Yes. So let's go with the compound angle here. So that BD is equal to x into, come inside, miss.
Morning, Miss Polly.
Morning, would you like to take over?
Yes.
Yep.
Guys, anybody from my history class here? No? Nobody? Cool. Thank you, Miss Polly.
No problem, miss. Okay. So sine 30 plus theta would be sine alpha cos beta plus the sine rule. Sine alpha plus beta. It's going to be sine alpha cos beta plus sine beta cos alpha. Is that not the case? Yes. Now in alpha's place we got 30 and beta we got theta.
Oh, that's right.
Nee, my kind. So it's going to be, now I forgot now, sine theta cos 30. And that is all over sine theta. Okay. Now, what we're going to do is we're going to put each one over its own. Okay, so on the outside, we have the x. No? Our x is on the outside. What is the sine of 30? Half. Not so. It will be half. Now, that is going to be cos theta over sine theta. What is cos over sine? 1 over 10. Okay. Which means to say 1 over 10 will be 1 over 2 tan theta like that. Plus, now you say sine theta cos 30 over sine theta. The signs will cancel, of course. Then I'm not left with cos of 30. Now cos of 30 in the special triangle is going to be 1, 2, root 3. The adjacent, which is the root 3 over 2. Okay. So yet, at this point, it still doesn't look like it. But what you notice, I can take out the half as a common factor here. Can you see that? So if I take out the half as a common factor, Then I'm left with x over 2 or half x into 1 over tan theta plus root 3. And that is exactly what they have here. Can you see that, people? The same. Okay. Now something like this is worth normally like 6 or 7 years, no? So now you think. Okay, that's if you want it. But as we say, most of us don't want it, no? Even when I tell you what theorem is coming in the exam, you tell me keep your 7 marks, I don't want it. No? Okay. So what I'm going to do is I'm going to take that off the board now, because we need the space. But remembering now that we have proven this, okay? Because normally what happens is we're going to need that in our next calculation, okay? Take it off. Okay. Now in number 2. Number 2 says we use blue, so let's use a different color. They want to know that you need to prove that the area of triangle BDC, BDC, the area of this triangle can be given by that one big thing. But looking at that, what already do we see? What do we see already from the previous calculation? We see the bracket is the same. Can you see that, people? So definitely I must pick up BD. Can you see that, people? Definitely we're going to pick up BD. How do we calculate the area in a non-right angle triangle? Of AB sine C. Not some two lengths and included angle. So if we definitely need to pick up BD, according to what we see, which other side are we going to pick up? BC. Why? So there's an x. And I say, hang on, there's an x squared. And that x that's coming from here times that x is the x squared. You see that, people? So when we're going to go with the area rule here, it's going to be, just clear this quickly. I don't want to have too much markings on the diagram. So this draw, we say intraangle BDC. Again we draw this triangle here on the side for ourselves. We got BD, C and X, and we got 30 here. We got theta, and we got 180 minus 30 plus theta. And then BD is this here. Can you see BD, the length of BD is that length. Michael, close your mouth. Okay. You see what you had for breakfast, no? Right. See, I forgot now. So we see we're going to use, so the area, you don't have to write this down. Area is going to be half BD times BC, sine of angle B, coming from this triangle now, no? Which is DBC. Alright. As I said, you don't need to write this. So it's going to be half. So BD is that long one, whilst BC is x. So it's half times x over 2, the square root of 3 plus 1 over tan theta, sine of 30 degrees. Okay. Sine of 30 degrees. Okay. So the area now is equal to, now x times x is x squared. 2 times 2 is 4. So it's a quarter x squared into the square root of 3 plus 1 over tan theta. Now sine of 30 is what? A half. And that half times a quarter is what? An eighth. So it's 1 over 8 x squared into square root of 3 plus 1 over tan theta. And there we have proven what they want. Easy, no? Laila says yes. Okay. It's important to know that if you're having issues here with this work, then make sure you understand your sine, cos and area rule or solution of triangles of grade 11. So this is an extension of grade 11. Okay? You all okay with this so far, no? Right, so let's look at what does question 3 entail. Okay, again, remember now that we got the area of this. Okay. Let's go with the last one. Number 3. In number 3, we are asked to show that AB is equal to this. AB is equal to that. I forgot to bring this up here. Now we are asked to prove that AB is equal to that. So what we notice again, people, what we notice now, again when this is coming up, can you see? Somehow or other there's that there is actually a root 3 that's multiplied throughout that bracket there. Okay, and then we got x over 2. So again there's a link between number 2 and number 3. Can you see that, people? Sorry, number 1 and number 3. Can you see it? You do see it. Okay. So if we're looking at AB, AB is this length. And we must use that length. So which triangle are we going to work in? So we're going to work in triangle ABD. What can I say? Again, I draw it. Do I have to draw this, people? No. Do I have to say which triangle I'm working in? No. You're that kind of girl that I want to write, it's going to do calculations. And then you don't have to do it. Okay, but for our own safety, we do it. Okay. So, again, what is BD? BD we have proven already. Okay. So which trigonometric function did we say uses opposite and adjacent? Tan. So tan of 60 equals opposite, which is AB over adjacent, which is x over 2 into the root of 3 plus 1 over tan theta. Can you see that? So how do I get AB on its own? Cross multiply. Okay. So tan of 60 works out to be what? Tan of 60. So it's 30. 1 to root 3. 60 lies there. Tan of 60? Root 3 over 1. So that's going to be root 3. You all agree with that? It's root 3 over 1. That is being multiplied by x over 2 into root 3 plus 1 over tan theta equals AB. Okay. So if we look at what we have here, we got x over 2 outside, so that I'm going to leave like that. So what must happen to this root 3? We multiply it inside the bracket. Can you see, people? So therefore, AB is equal to x over 2 into root 3 times root 3, 3 plus root 3 times 1, root 3. 1 times tan theta, tan theta. And they have just proven what AB is. People, you can't help but to love the sums. No? No, Layla, at least Layla is loving it. Alright, people, you guys understand? Okay, I'm not going to ask if there any confusion at this point. So I'm not going to do it again. Okay. Right, I've made a good couple of videos on the homework of this as well. You will find it in the description box below under full lessons. Okay. People, this double S here, 12 double S, means to say it's a shortened version of the lesson. Okay, it's examples only. Okay, so anyway on the page you see on the channel you see SS. It just means to say examples only. Okay. So that brings us to the end of 3D and 2D problems. The nice thing is, we're done with trigs for the year. But on the other hand, trigs count 60 out of 150. 60 marks out of 150. Okay. Alright, this works normally 10 marks. Okay. That brings us to a close on this.